Hey guys, Buildzoid here, and this is going to be a bit of a what I'd consider a filler video, but I don't know. Maybe you'll find it interesting. I'm like this is something I want to do, and I figured, hey, let's go through it together. So as you can clearly see, I have a lot of crucial memory here. Actually, you might be, yeah. Um, I thought they forgot about me because I actually requested review samples from Crucial like a while ago, and then I didn't really get any response from them for a while, and then this showed up today, and they couldn't have got worse timing as far as I'm concerned. Like I'm really busy with other things, and this showed up, and like I'm excited because we have a very large selection of Micron. Well, I'm not sure that all of it's Micron, but a very large selection of DDR4 here, and you know I do memory overclock. I'm not the world's biggest fan of memory overclocking. I'm definitely not the world's best memory overclocker, but I love overclocking. So I'm kind of excited to check out how all of these behave, how all of them overclock. And I'm like the problem is there's just kind of too freaking many of them. So I guess we're going to be doing like now I can do like a 64 gig test on Threadripper. Which I think these two sets will go well together for that. So we'll just be going through the DIMMs here. It's not really an well, technically I'll be unboxing every single one of the kits, but the thing is I want to take a peek around the PCBs. Now, I'm not checked if I'm allowed to pull off the heat spreaders. Even if I was allowed to pull off the heat spreaders, I wouldn't be doing that on video. That would take forever. Like, pulling heat spreaders on memory sticks is just not a very pleasant process. If you're ever going to pull heat spreaders, just be very aware that a lot of the time, like, it's not all DIMMs that do this, but there are a lot of DIMMs where the adhesive attaching the heat spreaders is stronger than the actual solder attaching the memory chips to the PCB. So if you just if you just pull on the heatsink, a lot of the time you'll pull the heatsink and the memory chips off, and you're gonna kill the memory stick. So don't do that. I normally do I normally use a combination of heat and alcohol to try weaken because iso alcohol weakens the adhesive on a lot of the thermal tapes that are used. But yeah, I don't know about these DIMMs, and we're not going to be taking them apart. We're just going to be looking under the heat spreaders to see what we can see, because even just looking under the heat spreaders should give us some idea of what we're looking at. Also, for comparison, I have a generic A2 memory stick here and a like I say generic. This is still a custom A2 design. This is I think an 8-layer or 10, might be even a 10-layer PCB, this one. Then we also have this, which I don't know how many layers this is. I think it's a 10, but this is, of course, the Patriot Viper Steels, Samsung B-Die. And I will have these for comparison because these have a an A2 layout with a lot more capacitors on it than what you'd see on other A2 sticks, right? Like it's still an A2 layout, but you can obviously tell there are some differences. So yeah, and we're just going to be comparing what Crucial's done with these because as I do believe that these are actually on unique PCBs that you probably won't see on, well, some of these, especially the Max kits, are probably on some pretty special PCBs. So I'm interested to see if we can see anything interesting from just looking at them. So I'm not sure really where to start. Let's start with a specific capacity, I guess. Let's start with the 16 gig kits. So we're gonna get rid of all the 32s and the 64. And this is a 16, so we're gonna keep that. That's a 16. We've also got a 32 of these. This is very interesting. I couldn't contain myself before starting the video, and I've already checked out a couple of these, so I already know these are really, really interesting. You don't see a memory kit like that very often, but and so this is 3000, this is 3600, this is 3200. I think all three of these are going to be the same thing, like same PCBs, same actually. Like I'd assume they're the same PCBs, but we'll see. This I expect to be pretty special. So we'll keep that for last, and we're just going to pull one stick out of each of these and take a look at it. So the reason why the PCBs are kind of important is that the memory manufacturers can sort of tune their memory for slightly different behavior with the PCB and what they do with it. So like if you do like, well, the biggest change is, of course, you can just use a different layout, which, like, if you have the memory chip space like that, that's an A2. But there's things you can do to an A2 to make it less like other A2. So, like this, I've heard from some people that this actually has, like, surprisingly good like, this A2 configuration actually has surprisingly good compatibility with, like, Z270. Where on Z270, there's a lot of motherboards that absolutely hate A2 memory sticks, but, yeah, I've not tested that myself, so I'm not, like, I can't tell you that that's 100% true. It's just something I've heard. And, you know, from somebody who I do consider actually capable at competent at memory overclocking. So I'm inclined to believe that that might actually be the case. Okay. Man, this packaging sucks to get into. Yeah. There. Okay. Here we've got the first set. This is the 3600, 16, 18, 18, 38. So 16, 18, 18, actually, oh, this is probably actually one of the ones on the special PCB as well. So the thing with Micron Rev E is that generally it does not do tight TRCD. Even at 3600, a lot of kits will not necessarily do 18 TRCD stable. And yeah, just looking at this, so this is not what I would consider... that is not what I would consider a standard A2. There's, like, let's see. Right, that's a standard A2 over here. You can see that instead of, like, these little resistor array components, we have individual little resistors, which is very, very unique. I don't think I have any other DIMMs that do that. So that's very interesting. Also, I think I'm looking at the back of the DIMM. Yeah, I'm looking at the back. But we still have individual resistors, so that is very, very weird. I've never seen that before. On this side, it actually looks more like normal A2. Though we have this extra cap down here and down there. So yeah, they've really changed some things about it. Not much looking through the side of the heat spreader. Yeah, it's pretty empty. I wonder if the chips might not be, like, jammed closer up to the... Nah, chips are in about the same location. Right. But, actually, no, they might be shifted down a bit. But, yeah, so this is not a generic A2. Which, I guess what they're doing with these is that this is actually, like, they may very well be optimizing the PCB to try force the TRCD lower. So yeah, that's interesting. I wish we could pull off the heat spreaders, but I'm not, like, I don't want to do that, so... I wish I had them naked. I wish they came naked. Or if they, like, the thing is, if you had a heatsink that wasn't just glued onto the sticks, it would add quite a bit of manufacturing cost, obviously, so that's why we don't have, like, bolted-on heatsinks, which would be potentially much easier to take off. So let's check at 3200. Yeah, so this is definitely a different PCB. So that is interesting. That is very, very interesting. Damn it. Go through the sticker, and let's get in there. I should have kept that stick out in the open, so that we could compare them side by side, but anyway, here we have the next set, and this looks far more like a generic A2 to me, though again, we aren't looking, like, it is a different PCB though. This looks far more normal though. So if we pull one of these, see, you can see that we don't have the completely, completely separate SMD resistors anymore. There's no caps on the outer edges. Am I on the back of the DIMM again? Yes, yeah. Yeah, so here's the memory chips. And yeah, this looks like a far more normal A2, right? There's no cap down in this area. There's a cap here, though. Yeah, this looks like a generic A2. We have the little resistor arrays. Right? Like, these two, so this looks like a, well, yeah, it looks like a this looks like a normal A2 layout. Well, I say normal. This already is not, like, if you went with the lowest option A2 PCB, it would actually look a little bit like lowest manufacturing cost A2. This is actually not that. So this is still like this is a relatively high-end A2. Like, you'd find this in some pretty fast sticks for B-die and that kind of thing. So, but this is not a unique PCB. This is not a particularly rare PCB design. So, And that makes sense. It's a 3200 DIMM. You probably wouldn't have to do much in the way of like special optimizations because this is 3200, 16, 18, 18. So if there are optimizations in this design for higher frequency or lower TRCD limits, then yeah, like this doesn't need it because it's slower. So yeah, it's kind of neat. Yeah, this just looks looks like a pretty normal A2 to me. So that's cool. And this is indeed, yeah, this is single rank, of course. You have only memory chips on one side. So, and no extra caps in weird places, so it's that one. And let's just go back to this one, but yeah. Actually, wait, I'll pick up both and we'll hold them up side by side because I find this really cool. Like, I wonder if it'll have any weird compatibility effects or I'd assume the main difference is like some of these, like this PCB might clock a lot higher maybe. Like that's the kind of thing I'm suspecting, right? So actually they're not the same side right now. There. This is the same side on both DIMMs. And you can tell there's a pretty significant difference in the SMD components, right? Like that is not the same PCB. Not even remotely. So that's pretty neat. So this is the 3600, right? And this is the, yeah, that's the 3600. So we'll put that one there. And put this one back. Man, I'm going to have a mess to clean up after this. We're going to go through all of them. And yes, at this painfully slow pace. So, because I'm interested in this. Like, this is, you know, I assume this is just going to be a completely normal A2 again. This is a 3000, right? Yeah, this is a 3000. So, this should be normal A2. And the sticker's already off at the bottom on this one. Up. So, this is going to be, I mean, we don't need to even pull it out of the packaging. Like, you can see that this is the same as that 3200 DIMM. So that makes sense, because, like, 3618, weird. 3218 TRCD, not weird. This is 3015, 16, 16. So this is actually Crucial's replacement for the, like, the 3000 CL15 DIMMs that I've showed off before as having, like, massive overclocking headroom. This is basically that again. So yeah, I'm probably we're gonna do some testing with it. Like, I'm definitely gonna be like, man, I'm not sure that I want to do like dedicated videos for every single one of these kits. So I guess I'm just gonna, like, I'm not sure how I'll test all of these yet. Like, on one hand, yes, I could pad for content by literally testing each kit individually. At the same time, that's gonna like this is gonna take forever. Right? So, like, shooting all those separate videos and that kind of thing, whereas if I just test it, write down the results, and mention that those are good, that I think is good enough. That would save me a lot of time at the very least, but yeah, this should just be some, you know, nice, low-cost Micron Rev E right here. Then once we get into the higher up kits, then that's when we start seeing the special ones. This is the 3000, so I don't... Bleh, running out of desk space. It's not like there was much desk space to begin with, but I'm running out. Let's take a look at the Max kit. So this packaging, I will say, is actually really nice. I really like it. And this, I think, is actually on the same PCB. Yeah, this looks like the same PCB as the 3600 sticks. Which kind of makes sense. Oh. We pull these much heavier DIMMs. These heat spreaders are much heavier. Not that they add much in the way of actual surface area, but they do weigh a lot more. And yeah, you can see we have the same kind of configuration of SMD components on there, right? Discrete little resistors instead of like resistor arrays. I think they're called resistor arrays when you have them all together in one piece. I'm not 100% sure that I have my component terminology there correct, but yeah, and then on the back, I mean, this looks exactly the same as the 3600 stick, except, of course, this is 4018 19, which is like, that is low TRCD. that is lower TRCD than what you would find on certain Samsung B-die bins. So that is very, very impressive. And do they actually have the full timing set somewhere in here? Nope. I guess it's on the DIMMs, right? Yeah, 18, 19, 19, 1.35 volts. This stuff, It has to be some of the like toppest bin Rev E you can find. So I am very, very excited to test these. These are like a kit of these was, if I'm not mistaken, used for the actual max, like the memory frequency world records that were done with the Micron revision E memory. That was done with these, or at least with this speed bin. I'm not sure if necessary. I think it might have been this PCB as well. So yeah, I'm excited to test these out. Yeah, we'll see what these can do. Man, okay, so that's the 16 gig sets gone through. So basically, once you go above, so this is actually, I can tell this is the 3200 by just looking at the PCB. There's don't need to try reading the spec when you can see that the componentry is different. So yeah, these are cool. I'm excited to test these. Man, it's been a like I'm excited that we finally have like what I'm really interested in testing is like high capacity configurations with this, because Rev E puts a lot less strain on your memory controller. Whereas if you run like Samsung B-Die, once you go over dual rank, actually on some platforms even dual rank Samsung B-Die is like a punch in the face to the memory controller. And essentially like, yeah, your timings are going to be really low, but if you're in dual rank, like the fact that you're in dual rank alone already offsets some of the timing differences. So the goal in dual rank is generally just to max out the frequency. And for that, Rev E should be perfect. So yeah, also often referred to as Micron E-Die. Anyway, I am excited for these. Man, why can't they all have the nice max packaging? Okay, so that's the 16 gigs, right? Did I go through all of the 16s? I think I did go all of, yeah. Or, right, I already put one away. That's why I can't find it. So, let's move on to the 32s. Let's not start with these because these are special. That's a 64. Let's put those out of the way. This is a 3000 dual rank. I'm assuming dual rank. Let's see. Let's be surprised. But if this isn't dual rank, I'll be very surprised. So, these have RGB. RGB, like the way RGB is normally implemented is there's a bunch of unused space on the top edge of a memory stick, so they just kind of whack it up there. It doesn't really do anything. Like, I know there's a lot of, like there's been a lot, well, there used to be a lot of discussion, like, oh, does RGB make the memory sticks clock worse? No, it doesn't. It's like, well, I guess if you had a badly implemented PCB design, but, you know, like, you're not going to get that with, like, Crucial or someone like that. But theoretically, a badly implemented PCB, yeah, you might have problems because of the RGB, but if the manufacturer knows what they're doing, then the RGB is going to be on the top edge of the DIMM where there's basically nothing up there, so... yeah, that's not really a concern. Anyway, so this looks like a pretty... Like, unfortunately, I don't have a lot of 16 gig DIMMs. In fact, I only have two 16 gig DIMMs before Crucial sent this pile of memory to me. And so I don't actually have a comparison point for these, other than, like, a set of Corsair Dominators that I know for a fact aren't very normal in terms of the PCB. Like, Corsair's Dominators are pretty unique. So it's not really, like, it's, in my opinion, it's not really worth comparing against. Interesting is this does not look like, so as far as I know, normally what you get for dual rank DIMMs is you get an A2 layout and then it just gets sort of, both sides of the DIMM look like an A2. And this definitely has the A2 spacing where you have one group of ICs and then another group of ICs and then the same on the back. But there's a bunch of extra capacitors in there. So, yeah, that's interesting. I'm not sure if that's standard, but yeah, that's not something I've seen before. I don't think my Corsair DIMMs have that. Actually, I should have grabbed the Corsair DIMMs. It's too late at this point. Like they're buried in the pile of RAM. Like, yeah, they're buried somewhere in the pile of RAM. Anyway, I might do a closer comparison between the 16 gig DIMMs and the Corsair 16 gig DIMMs later when I actually get around to testing these properly. But yeah, this doesn't, like, I'm not sure that this is a completely normal B2 layout. So for those of you unaware, the memory layouts, you have like A0, A1. A1 is a ECC layout, so you don't really see it on enthusiast grade memory kits anyway. You do see it on like budget RAM for, well, yeah, you see it on budget, used on budget memory because it's an ECC layout, so you can print one PCB, but use it for both ECC and non-ECC memory kits, which obviously is a nice little cost-saving thing for the manufacturer. Yeah, so this is a 3200. This is different. Yeah, you don't see that PCB used very often. Then there's A2, which is the current sort of norm for high-end memory, because it clocks really well. And after, like these days, the BIOSes of most motherboards are actually designed to work well with A2. So A2 is the preferred layout for high-end kits these days. And for dual rank sticks, the main difference is that they're referred to with the B layout. So you'd have a B0, which is a A0 sandwich. Then you'd have a B1, which is an A1 sandwich, as in you have an A1 layout from both sides of the memory stick, essentially. And then you have B2, which is A2, but sandwiched again. So now, I really hate this packaging. Man! Okay, there we go. Ow. Ow. Okay, ow. Stabbed myself with that. Anyway, so these, you can already tell, these do not use the resistor arrays. I should have kept that 3000 kit out. I mean, you can kind of tell through the packaging there, right? Like, that is a different arrangement of SMD components. So let's see. I'm not even sure if this is still dual rank, though. Okay, so yeah, this changes out the resistor arrays for discrete resistors, which is interesting. It is still dual rank, right? So we have one set of ICs on this side, another set of ICs on the back, and there's some extra capacitors in there. So this looks like it might even be the same PCB, but they've just replaced the SMT resistors. So that's interesting. And this is 3200, 16, 18, 18. So, like, in theory, this should have, like, this is a speed bin that I'd assume probably works just fine on a generic B2 layout, but Crucial, obviously, seems to have decided that they want to go a bit further. Like, actually, no, that is very different. Like, because these are, like, like, this resistor array over there has, like, 8 legs. So, no, this is a completely different PCB. So, I was wrong about that. This is very different. So, let's get to... Do I have another 32? I do believe I have a 32 by 16. I mean, 2 by 16, 3600 kit. This is another different PCB. Are you kidding me? Really? Okay, wait. We're gonna get the... Like, I'm gonna keep this open now because... That is very interesting. Now, dual rank is interesting in that it's a pain for the memory controller, and it's very, very, very sensitive to the BIOS knowing what to do with it. So I find it very interesting that Crucial has all these different PCB design, like PCB variants, I guess. I'm not sure if they're... Oh no, this is actually on the same as the 3200. I mean, on the as the 3000. So that is very interesting. And the speed bin on this is 3600, 16, 18, 18, 1.35 volts. So this is quick for Rev E. That is very... Right, let's get these out. So, man, I kind of want to compare it against but yeah. Right, you can see we have different component arrays down here. And same on the back. So this actually looks like the 3000 kit, not the 3200 kit. So that's going to be interesting. I guess I'm going to have to test like the 3200. Like at the same time, there's obviously binning differences. So you can't go like, oh, if this clocks significantly better or if it times significantly better. You can't necessarily blame the PCB for that because it's like, well, this is also binned 400 megahertz higher than this, right? So I'm not sure how accurate Crucial's binning process is because I've not run a lot of Rev E. And for, say, Samsung B-Die, the binning process is all over the place. Some of the best B-Die memory kits I've heard of were like 3200 CL14 sticks. At the same time, I've also heard of like terrible or not that impressive 3200 CL14 sticks. So yeah, I don't know. Maybe Rev E is easier to sort, as in it's far, like if you have a 3600, it's definitely going to clock better than a 3200, which is definitely going to clock a bit better than 3000. Or maybe it's like B-Die where it's just kind of all over the place and you can get, like I have a kit of 4600 CL19 B-Die that's honestly kind of terrible. And it's really disappointing because you'd think like that's a crazy speed bin, right? It has to be amazing, and then you run it and it's like, oh, it's not. Wait a minute. I think I just swapped. No, this... Okay, no, this is 3200. Okay. Ah, man. Got confused. Got very confused there. They all look the same. Oh, boy. But yeah, so you can't necessarily, like, if I find a major overclocking difference between these two, you can't really blame the PCB for all of it, because I don't know if there's obviously a bin speed difference. So yeah, but one thing, like, if there's some weird, like, if I run this on one, if I have if I go through a bunch of different motherboards and I find that this kit consistently has, like, some timing that needs to be really loose or something, then we can conclude that there's actually, like, significant difference there. Like, there are certain PCBs where if you stick them into certain boards on certain BIOS revisions, you need to jump through hoops to achieve the same thing like, the same settings that would work just fine on a slightly different PCB layout. So, man, okay, so we've gone through those, and let's take a look at the 32 gig, 4000 megahertz Ballistix Max. Okay, so, these are very, very different. So far, everything has been using double-sided PCBs, so B series layouts, so B2 of various levels of alteration. Well, actually, 2 different flavors of B2 from Crucial on the kit so far. This, however, is not B2. This is single rank, which is very, very interesting. Because that means these are 16 gigabit Micron memory chips. See that? Those are some fat memory chips. Also, we still have the, like, individual resistors for the connecting the memory stick to the pins. And on the back we have nothing. There's no memory chips on the back. They're only on the front, and the ones on the front are very fat. So this is some kind of 16 gigabit Micron. I don't even know what the name for that is right now. It's not Rev E. So this is some different IC. And actually, I recently tested a Micron-based 32, like some Micron-based 32 gig DIMMs from a different vendor, and those did some very interesting timings. Like, they weren't as loose as what I'm used to, but they didn't clock very high, which might have been down to the fact that they were dual rank, might have been down to the fact that the binning wasn't so great. Like, that was a 3000 CL16 kit. I only got it up to 3666, so I was kind of disappointed with that. This is obviously rated for 4000. So I wonder, like, if this still does the same tight timings as the previous Micron 16 gigabit kit that I tested, then this stuff might be really, really good for just, like, high capacity, high frequency setups where, you don't have to, like, because the thing is, like, my biggest problem with regular Rev E most of the time is that the timings just don't get that tight. So, it's not really, like, it's cool. It's a cool memory chip if you're into memory overclocking and you want to do, like, high frequency runs. And it's, as far as I know, it also scales with sub-zero, like, it scales really well with sub-zero temperatures from what I've heard. I've never run it sub-zero myself. Yeah, this stuff I've not really seen too much coverage about, and so I'm very interested to see how it behaves in single rank with a 4000 speed bin. This could also be completely different memory chips from what I've tested, so, like, what I tested in the past. So I guess we'll see. Let's move on to this. So this, I do believe, has to be a B3 layout because this is a 64 gig kit using 32 gig DIMMs. So we're going to have the same fat memory chips. So those fat memory chips, they actually use a different layout because you can't put them on the regular layout. So actually, this is an A3 PCB layout, if I'm not mistaken. Like, I'm assuming this is some variant of A3 because as far as I know, you can't put those massive memory chips on a regular, like, you can't put those on a regular A2. It just doesn't fit. So, yeah. Man, I'm excited. I'm very excited by this. Unfortunately, they really just nailed the timing, right? Like, I have Z490's coming out soon, and I am very busy. It's not like I didn't already have a backlog of stuff to do to start with, and then this shows up, and it's just like, well, I guess I'll die. I'm just gonna clock memory to exhaustion. I'm gonna pass out over the keyboard while running memtest. Because Crucial decided that, the best time to get all the memory to me is in the middle of Z490, like between the various Z490 launch, like NDAs. Okay, let's get these out. Up. So this looks like another pretty normal B3. Yeah, we're using the no individual little resistors everywhere. So this looks far more normal. 3200 CL16. I'm excited to see how this clocks. RGB. Yeah. Actually, these memory chips aren't fat. What the hell? Right? Like, wait. Oh no, they're... Yeah, wait a minute. Now I need to compare to a regular sized memory chip. Let's grab these. But those don't look as fat as I thought they should be. I should have grabbed a 30... Actually, I'll go grab a dual rank 16 gigabit Samsung sticks to show you fat memory chips. Because it might not make a lot of sense to somebody, but... Nah, they're fat. They're fat, but they're not as fat as the Maxes, I don't think. Actually, the Maxes might be on a dual die package or something. So now I'm really confused what's what. Yeah, these are pretty fat, but this is still a pretty standard layout, I think. Like, I think that's the same... It looks to be the same PCB as this. So that is very, very interesting, because I do know, or at least I think I know, that Micron does have a 16 gigabit dual die package of Rev E, which is essentially 2 rank, like, instead of, so normally you have like 1 piece of silicon in each memory chip. But for high density applications, there's a variant where you put 2 chips, 2 pieces of silicon into each memory chip, and that's called a dual die package. Essentially, you get a dual rank memory chip without having a double-sided PCB. And I'm not sure that actually, like, if that has frequency advantages over regular dual rank, it might have better compatibility with motherboards. I have no idea. I've never run it. It's like I've heard of it, that it exists, and I've always assumed that you only see it in server hardware. So yeah, I'm really not sure what's on that, but that is very interesting. I'm excited to, like, now I'm really excited to play with that, and I'll go grab the fat 32 gig DIMMs Samsungs. I'm not gonna bother with closing that, so I'll go grab the other memory stick for comparison. Just gonna put this one away, and yeah, let's go grab that other stick. Okay, so here is, yeah, and I have these signed so that I don't lose them, because I was bringing them with me on a trip, so I didn't want to. They look like generic green Samsung sticks, so I didn't want to lose them, so just have them marked. But yeah, see, these are fat little chips, and these are normal chips, and obviously, well, this is actually probably, now that I look at it, Crucial might be using A3 on everything. Because I think this is a B3 because you can see how, like these chips don't fit on an A2 or they don't fit on an A2, they don't fit on a B2. Because, yeah, you normally have those gaps between the chips and you can see there's little like SMDs in between there and they're not in a straight line. Whereas on a stick like this, those SMDs get jammed into a line because there's just no more space in between the chips. And it kind of looks like Crucial might be using that PCB everywhere. They might be using A3 everywhere. And then still have their own like spin of it for some of the DIMMs. So yeah, these are interesting. Like these are some very interesting memory sticks from Crucial. I'm very excited to get to test these. Actually, let me just check something. So this actually... No, but this can't fit fat chips. Yeah, there's no way you're fitting these onto this. So... Man, I really wish you could get more details on the different memory PCBs from the various manufacturers, but... Like, the thing is... like, my understanding is that there's JDEC layouts, which, like, something like this would be a JDEC B3. And those come from the actual, like, Samsung has a, reference A2 design, and that's this. And this is a very low-cost PCB because we only have components on the one side, right? Because you'd have to do multiple reflow steps to get the components on both sides. And so far, every single stick we've seen from these Crucial kits, like you can see Crucial's not saving money because they don't have any blank back, like memory sticks with a blank back. Because if you have the blank back, then that's one less step in manufacturing essentially that you don't have to do. So this is like a cheap A2 layout, as far as I know at least. But the thing is, you can take, and at least within my understanding, the various memory manufacturers, if they're building actual like high, more performance-focused kits instead of just commodity kits like you have here, because this is the kind of thing you'd find like in a Lenovo or an HP or a Dell, and if it was ECC, then you'd see it in a server, right? Like you don't need memory that goes to 4,000 megahertz at tight timings in a server, just because servers don't, like, it's outside of JEDEC spec and nobody wants to overclock their servers that much. Or at all, really, most of the time. But, yeah, where was I going with that? So, you have sort of the standard layouts from, like, that are like that, and then the various memory manufacturers, like Crucial. Like, Crucial's definitely big enough to do their own PCB designs, and they manufacture them as well. Like, Crucial's owned by Micron, so, Micron makes memory chips. Crucial can kind of have a lot more control in some things than, I guess, other vendors, because of that, because they're just, part of an actual chip manufacturer. But with the, I'm not, I don't think, this is not a unique PCB layout to Patriot, because I've seen it on other sticks at this point. So I don't know who actually, whose design this is, but it's not a regular A2. It's definitely better than a regular A2, right? You have the components on both sides. See them on the back there. But this is like an upgraded A2, and then we obviously have the original upgraded A2, right? Where there's components on both sides on this, because, and you can actually see there's some differences in the traces over here versus here, so, but this is it still uses the general A2 layout, so, if a motherboard has a hard time with this stick, it'll have a hard time with this stick also, almost certainly. And the same goes for this. If the motherboard doesn't play well with A2, it probably won't play well with this. But at the same time, it is possible that, whoever, this PCB could be optimized for working better with more motherboards. So yeah, I find the PCB memory stick PCB layouts kind of interesting. Unfortunately, there's just not that much information that you're well, I'll see if I can ask Crucial if they have things that they could share about their PCB designs, if they're specifically geared towards, I'd suspect that they're geared towards low TRCD very specifically, because As far as I know, nobody else does a 4000 TRCD 19 Rev E bin. Like, it's just an unheard of. I think the most aggressive Rev E bin from like, well, like basically all the Rev E's once you go above 4000 megahertz, all the bins from the other vendors, you're looking at TRCD 21, TRCD 22, 23, 20, up, all the way up to like 26 TRCD. And here we have Crucial where it's like we're doing 4019, right? Like the Max kit is doing 4019, which this one is too, which is actually kind of ridiculous. Like this is a very aggressive speed bin. Like I'm very excited to play with that because I have no idea what those memory chips are. B, that is a very aggressive bin for a 16 gig for 16 gig sticks in general. Like yeah. So these are very very interesting, and it's just cool like Crucial doing it's just cool to have a lot of like variety like this to in memory overclocking in my opinion, because obviously like I just love overclocking even though I don't necessarily love fiddling with memory timings that much. But yeah, so this will be interesting to test all of these, and I guess thank you Crucial for the absolute stack of memory they sent me. Right? This is, in total, it's 256 gigs of DDR4. So we will definitely be doing some, like, I want to do some triple rank tests with this stuff, because, like, why the hell not, right? Like, there's a lot of, like, so what I mean by triple rank is we could take, like, this 3200 kit, which, yeah, that uses a pretty normal looking, and we could take, say, this 3200 kit and put them together, because this is a dual rank set. This is a single rank set. So if you put them together, you can actually do triple rank, which is pretty fun. Or if we put two dual rank sets together, we can do quad rank with this, or like this, or really like whatever I decide, right? So yeah, I'm excited to play with all of this RAM. This is so much DDR4, and yeah, hopefully, like I'm hoping for some interesting like behavioral differences between the various sticks, but we might find that it all behaves very very similarly. I'm not yet sure on which motherboards I want to test all of it. I've heard from somebody that the Z490 Phantom Gaming ITX, which I've never seen that board go over 4533. I've heard from somebody that apparently if you run Rev E on it, or Crucial Rev E, I'm not sure if, like, I heard they used a Crucial kit. Apparently with a Crucial memory kit, they were doing like 4800, so that would be, that's one thing I want to check out, because that's just kind of cool being able to do that kind of frequency. On a board like I've never had it above 4533. So if one of these kits can make that board go up much higher, that's just kind of interesting. I really want to test the 16 gig DIMMs on a whole bunch of motherboards, because well, so far my experience with 16 gig DIMMs has been very bad, but here we have a very large variety of 16 gig DIMMs, and it's also all different memory chips from what I've tested before. So yeah, I'm excited to see what they do, and yeah, like I think like we'll just see. Like I'm really like I'm kind of overwhelmed to be completely honest with because I was like if I remember correctly, I requested one set of 2x16, and then this showed up, and I'm like, well, I mean, I won't say no to testing these, right? Like, but man, that is a lot of RAM. And just like there's also so much variety to it, right? Like there's I think for every capacity there's at least two different PCB designs here. And we have speed bins ranging for every capacity, well, except for these, but for all the other ones, like they've sent me bins from 3000 all the way up to 4000 TRCD 19. And yes, I do actually focus on the TRCD component so a lot, because like 4019 TRCD is hard for literally everything that isn't BDI, so it's kind of amazing to me that Crucial has that as an XMP bin. Like, that's insane. And yeah, so I'm really excited. So, oh my god, this video is 40 minutes. Well, RAM. There's kind of a lot of RAM. So yeah, anyway, this is actually it for the video. If you have any, actually, no, it's not. If you have any suggestions for what you'd like what platforms I should test with these, I'm going to be doing some Threadripper with it, just because, you know, like, I've not tested any high capacity stuff on Threadripper, and I know some people are interested in it, so I'm probably going to be testing, actually, I have enough here's the problem. Like, I'm pretty confident that if we mix... Like, the fact that this is a single-sided PCB, possibly dual rank, I'm not sure. If this is a single rank like, if these are single rank sticks, then trying to run all 4 kits together on one motherboard is probably going to work really badly. If this is dual rank, which it might be, because it could be dual die packages, I'm not sure. Like, the chips are huge, so I've never seen chips like that before, and we can't pull off the heat spreaders yet, so that sucks. But the thing is, like, there's a real, like, I have a real concern, whereas if you mix very different PCB layouts, that it causes problems, because I've dealt with that before, and it's just like, because you might have some slight timing differences or termination requirement difference, like, different termination requirements especially would be a real problem, where it's like, what's necessary to run one stick, like one set well, it doesn't, like, it screws up the other set. So it's one of the concerns that I have with this. But like, all of these, like, these all should work relatively well together. This is really special. This is really different. So I'm not sure how that'll play with it, but definitely I can test, you know, a 64 gig. I mean, yeah, I can definitely test a 64 gig Threadripper setup with these. We can test a we could also test a 96 gig Threadripper setup, where I take, like, this, and these two, and put that together, so that's going to be the triple rank monstrosity, and that should work fine. It might need me to juggle the DIMMs around a bit, but it should work fine. I've run it before. I kind of want to do some testing with X299 with these, and, like, well, there's just so many platforms I could test it on, right? But, and now my voice has decided to give up. I've been talking too much already. Anyway, yeah. So if you just have anything that you're, like, really specifically interested in, for me to test with these, then leave a request in the comments. I may or may not have the motherboard you ask for. There's a reason why I like to keep a ridiculous stack of boards. Like, it's so that I have, you know, so I can show different kits, like, so I can test memory kits on different vendors, because sometimes, like, different motherboard vendors, yeah, so leave comments for what you're interested in, because I, quite frankly, have no idea what I'm going to test first. So, because there's just kind of too much memory here. Because the thing is, I'm used to, like, I could probably do, like, I could test one set here, right? Like, say this set right here. I could test this on Ryzen. I could test it on Z390, Z490. It doesn't make sense to test a single kit of, like, this on X299 or TRX40, in my opinion. But definitely, I could test it on Z390 and X570, and that's already, like, 2 videos. And, you know, if I'm running 400% mem test, that actually takes a while. Just in terms of occupying resources that I have, like, it takes up a power supply, a hard drive, motherboard, my desk. That's another concern, is just how much desk space I have available. But yeah, so it's cool that I'm not sure how I'll tackle these. It's just so much freaking RAM. Anyway, now I'm actually done. So thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon where you can support me directly. There's a link to that down in the description below. It helps out immensely with running the channel. Other than that, if you'd like to support, other than the Patreon, there's also the HOC Teespring store, where you can pick up shirts, stickers, posters, and, you know, the usual YouTuber merch. I would kind of not recommend actually using the Teespring store, considering current events right now. You can definitely, like, once, you know, things return back to normal, Teespring works really well. But I've heard from some people right now, like, just in general, it seems like shipping around the world has been kind of screwed up, which might be part of why these showed up as late as they did. Yeah, like, there's links to Teespring and the Patreon down in the description, so if you'd like to support me through those are available. And yeah, that is it. So thanks for watching, and also thank you to Crucial for all of this memory. and goodbye. I don't have enough space on my desk for the mouse anymore.